Hello everyone, I'm Alexis Montolier from the University of Caen. The presentation gonna be in English. Yeah. And today I will speak about design tactics observatory for handball. First, let me introduce what is invasive team ball sport. It's complex relationship between a player that lead to cooperation and competition. You have an offensive team who want to keep the ball and score into the opponent target, and a defensive team, and role can be reversed. So I ask the question: how to analyze tactics in team sport? We are gonna work on World Championship of Handball data. In our data set, we have 88 international level matches, and these data are provided by Marco Cardinali and obtained by video analysis and manual annotation of events. So we got spatial temporal and event data. So first, for tactics, we need I'm from computer science, so we need the informatics structure to mine the pattern, and we choose to build dynamic graph. Why dynamic graph? Because we want to create to have the team to cap the team play. So graph are for this reason. We have node. Player is a node. It's simple. We can add as a node positioning in the zone, possession of the ball, but how do our players relate to each other? A simple thing is teammate opponent proximity ratio, but it's not enough. So we decide to partition the playing area. We use Voronoi diagram. What is Voronoi diagram in team sport? It's a partition into zone that can be covered before anyone else if all players have the same speed. And this is how we create a relationship between a node with Voronoi and its dual, Delaunay. We create a link, an edge, when two partitions touch each other. In blue, you have a teammate relation, and in red, you have opponent relation. But Voronoi, it's computed on a polygonal space, and as you can see, the zone around the goal, this zone, player can't be there, but it's curved. So we use a gnomonic transformation to uncurve this zone to have a straight line. As you can see, defense around the zone as a wall, and when we do the transformation, we have a better understanding of this situation. As you can see, we don't have relation between wings, and according to the expert, we need to have them. So when we do the transformation, in this space, we compute new Voronoi in this space, and we curve back to have the initial space, and we got a new relation. As you can see, we got more relation on wings, and it's more realistic according to the expert. On the left, you have relation loss, and on the right, you have relation gain. So we lost relation between wings and goalkeeper that are not really necessary, but we gain a good relation between wings and back. So Now we know how to have a dynamic graph, but how we mine in them. So dynamic subgraph mining is not good because we have a dimension problem. It's expensive and it's in a match we have many subgraphs, and the subgraphs are not really interesting and easy to read. Too many subgraphs, so we need to isolate game phase. It's for this reason we transform our dynamic graph to sequence. We decide to have sequence of 5 pies before a shot. Why 5 pies? Because according to experts, it's the number of passes to create a tactics. So each time step of our sequence is a pass. Because we need to make a pattern readable by an expert. And after that, we extract from the match the sequence leading to a good shooting situation. But we need to catch rapid change in the game. It for this reason, in our sequence, we compute the difference graph. On the left, you have the initial graph. On the middle, you have the graph at the next step. And we decide to compute another graph when in dash you have a relation lost between one time to the next, and in a plane you have a relation that have been created. After that, we use a closed sequential pattern extraction algorithm. With a graph, it's seen as an edge set. So the dynamic graph is seen as a sequence of edge set. This representation considerably reduce the number of patterns found without loss of information. Moreover, we catch rapid change in the dynamic. Another thing is because we don't mine on dynamic graph, we have no graph isomorphism problem. So with the algorithm, we have many subsequences or tactics, but frequency is not enough. We need to add measure to sort our tactics. So we introduce two another measure, the emergence rate. It's a ratio of if the tactics lead to a successful goal or unsuccessful goal. The expected goal, it's a measure that gives the probability of scoring at the end of the sequence. After that, we can develop an handball observatory with different area to let coaches and experts navigate through the tactics. In zone 2, you have the controller that lead to the pattern, and in zone 4 you can have many information on the pattern. If it's a counter attack or place attack, the XG, time for the pattern, the triggering, etc., etc. And you have pattern information 2 in 3. After that, we have many tactics, and the relevancy measured by size. So we have tactics of 2 pass, 3 pass, 4 pass, and 5 pass. That lead to 6,820 tactics. That lead to 1.5 more goal than no tactics. We have an expected goal at the shots of 58. So when we use our tactics, 58% chance to have a goal. So thank you to listen to me.
Thank you. Thank you. Merci beaucoup, Alexis. Merci. Any question? What we can see here is that you are using quite a huge amount of data. Is it open data or your own data? Is it easy to access?
No, it's private data by Marco Cardinal. He just gave us after many contacts.
Okay.
But
So
it's not open.
It's not really open. It's
Yeah.
not really open data, right?
Yeah.
I think this is one issue in this area. I mean, we don't have access to all the data. Some of the data is also secret, right?
Yes.
Because it's related to the.
Yes. The data set is quite large, but we decide to just use trajectories data.
Trajectory data which are provided.
Yes.
Which are. Any question? Yes. Next time go down.
Yeah. Thank you for the presentation. I'm speaking in English. So the second bullet point, is that so all tactics, like is the way to interpret that if you use tactics, you're more likely to score goals, like period?
When we mine a number of tactics, and each tactic lead to more goals, 1.5 more goals. And I don't know if that's the question.
Yeah. So then, so it doesn't matter like which tactic you use. It's just like any.
I can show you maybe an example of the observatory. For example, this is one tactics, and on the right we can in red it's the edge invoked in the tactics, and we can just go through the tactics on show what is working for the tactics. And as you can see, for example, this pattern is a tactics understandable by a handball expert, and these tactics led to 6 more goals than no goal. As you can see, in this zone, we have different match. We can see when the tactics occurs. In green, the tactics lead to goal, and in red, the tactics lead to no goal. And handball expert, coach, for example, can navigate into this specific situation. For example, if I click on red, and I can see why the tactics don't lead to goal. Sometimes it's just because the goalkeeper was better.
So the goal, you want to have like the coach using this tool.
Yeah.
Okay.
It's a tool for coach.
Merci, très cool.
Is it actually used?
It's actually used by the handball, and since they start using it, they start winning.
So are you planning to run your own company and start up a company?
Maybe, yes.
Become the very good. Thank you so much. Thank you.